NASA is set to launch its next-gen solar sail into deep space. Everyone knows that solar energy is free and almost limitless here on Earth. The same is true for spacecraft operating in the inner solar system, but in space the sun can do more than provide electrical energy. It also emits an unending stream of solar wind. Solar sails can harness that wind and provide propulsion for spacecraft. NASA is about to test a new solar sail design that can make solar sails even more effective. Solar pressure pervades the entire solar system. It weakens with distance, but it's present and it affects all spacecraft, including satellites. It affects longer duration space flights dramatically. A spacecraft on a mission to Mars can be forced off course by thousands of kilometers during its voyage by solar pressure. The pressure also affects the spacecraft's orientation, and they're designed to deal with it. Though it's a hindrance, solar pressure can be used to our advantage. A few solar sail spacecraft have been launched and tested, beginning with Japan's Icarus spacecraft in 2010. Icarus proved that radiation pressure from the sun in the form of photons can be used to control a spacecraft. The most recent solar sail spacecraft is the Planetary Society's LightSail 2, launched in 2019. LightSail 2 was a successful mission that lasted over 3 years. Solar sail spacecraft have some advantages over other spacecraft. Their propulsion systems are extremely lightweight and never run out of fuel. Solar sail spacecraft can perform missions more cheaply than other spacecraft and can last longer, though they have limitations. The solar sail concept is now proven to work, but the technology needs to advance for it to be truly effective. A critical part of a solar sail spacecraft is its booms. Booms support the sail material. The lighter and stronger they are, the more effective the spacecraft will be. Though solar sails are much lighter than other spacecraft, the weight of the boom is still a hindrance. And NASA says booms have tended to be either heavy and metallic or made of lightweight composite like a bulky design, neither of which work well for today's small spacecraft. Keats Wilkie, ACS-3 principal investigator for NASA, says. NASA is about to launch a new solar sail design with a better support structure called the Advanced Composite Solar Sail System, ACS-3. It's stiffer and lighter than previous boom designs, and it's made of carbon fiber and flexible polymers. Though solar sails have many advantages, they also have a critical drawback. They're launched as small packages that must be unfolded before they start working. This operation can be fraught with difficulties and induces stress in the poor ground crew who have to wait and watch to see if it is successful. ACS-3 will launch with a 12-unit 12U CubeSat built by Nano Avionics. The primary goal is to demonstrate boom deployment, but the ACS-3 team also hopes the mission will prove that their solar sail spacecraft works. To change direction, the spacecraft angles its sails. If boom deployment is successful, the ACS-3 team hopes to perform some maneuvers with the spacecraft angling the sails and changing the spacecraft's orbit. The goal is to build larger sails that can generate more thrust. The hope is that the new technologies verified in the spacecraft will inspire others to use them in ways we have not even considered. Alan Rhodes, ACS-3 lead systems engineer, NASA's AIM Research Center, says. The ACS-3 boom design is made to overcome a problem with booms. They're either heavy and slim or light and bulky. Booms have tended to be either heavy and metallic or made of lightweight composite with a bulky design, neither of which works well for today's small spacecraft, says NASA's Keats Wilkie. Wilkie is the ACS-3 principal investigator at Langley Research Center. Solar sails need very large, stable, lightweight booms that can fold down compactly. This sail's booms are tube-shaped and can be squashed flat and rolled like a tape measure into a small package, while offering all the advantages of composite materials, like less bending and flexing during temperature changes, he said. ACS-3 will be launched on an Electron rocket from Rocket Lab's launch complex in New Zealand. It'll head for a sun-synchronized orbit 1,000 kilometers at 600 miles above our Earth. And once it arrives, the spacecraft will unroll its booms and deploy its sail. It'll take about 25 minutes to deploy the sail, with a photon gathering area of 80 square meters, or about 860 square feet. That's much larger than the Light Sail 2, which had a sail area of 32 square meters, or about 340 square feet. And as it deploys itself, cameras on the spacecraft will watch and monitor the shape and symmetry. The data from the maneuvers will feed into future sail designs. 7 meters of the deployable booms can roll up into a shape that fits into your hand, said Alan Rhodes, the mission's lead systems engineer at NASA's AIM Research Center. He said the hope is that the new technologies verified on this spacecraft will inspire others to use them in ways we have not even considered, he said. ACS-3 is part of NASA's Small Spacecraft Technology Program. The program aims to deploy small missions that demonstrate unique capabilities rapidly. With unique composite and carbon fiber booms, the ACS-3 system has the potential to support sails as large as 2,000 square meters, or about 21,500 square feet. That's about half the area of a soccer field, or as our UK friends mistakenly call it, the football field. With large sails, the types of missions they can power changes. While solar sails have been small demonstrations models so far, the system could potentially power some serious scientific missions. The sun will continue burning for billions of years, so we have a limitless source of propulsion. Instead of launching massive fuel tanks for future missions, we can launch larger sails. They use fuel already available, said Rhodes. We will demonstrate a system that uses this abundant resource to take those next giant steps in exploration and science. Solar sail spacecraft don't have the instantaneous thrust that chemical or electrical propulsion systems do, but the thrust is constant and never really wavers. They can do things other spacecraft struggle to do, such as taking up unique positions that allow them to study the sun. They can serve as early warning systems for coronal mass ejection and solar storms which pose hazards. The new composite booms also have other applications. Since they're so lightweight, strong, and compact, they could serve as the structural framework for lunar and Mars habitats. They could also be used to support other structures like communication systems. If the system works, who knows what other applications it may serve. This technology sparks the imagination, reimagining the whole idea of sailing and applying it to space travel, said Rudy Aquilina, project manager of the solar sail mission at NASA Ames. Demonstrating the abilities of solar sails and lightweight composite booms is the next step in using this technology to inspire future missions, said. This was published originally on Universe Today by Evan Go. It's on Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.